Hello and welcome to BIS 205. And for those that have been in the previous session with PostFinance, we continue with banking in the cloud. And again, we are using cloud native services and also serverless technologies. But this time I have Joël and Didier from Avaloq with me. Avaloq is a software banking provider, also SaaS solution provider. And we talk about how Avaloq is modernizing their core, a topic that many of my customers have at the top of their list, modernizing the core and how to do so. Today in this talk, we start with a short overview from my side about what our customers are doing in this area. Then I hand over to Joël for more like the business drivers behind the idea. And then Didier will dive deeper into the technology aspects of the solutions, where he also is highlighting the key lessons learned of building such a system in the cloud with native technology. When I started like 20 years ago with Swiss banking, there was like a project called Mainframe Exit. And the ambition was that everything that was on the mainframe should be rewritten in Java and should be building then the core of the bank. Now, believe it or not, 20 years later, that mainframe is still running. And one of the reasons is that a lot of the innovation after that, like e-banking, mobile banking, business process automation, etc., has been built around it. Innovation happened around the core, and the primary pattern was to build an integration layer, a business facade, whatever pattern you like to use, and then integrate the new world with the legacy world. And this was a good way of kind of avoiding touching the core, but still building new solutions, innovating and using latest technologies. But lately, this has become more and more a challenge. While innovation here was more like outside of the core, we now see more and more requirements that address directly the core and the features in the core. So one example is instant payments or payments in general. Instant payments was something that a lot of banks had problems with because their payment solution in the core was not ready for that. They used batch processing, the data model was not ready for it, and they actually had either the solution of rebuilding the whole payments or building it outside. Another challenge this year is for most banks to adopt the ISO standards, again, payments area, but also other regulatory requirements, know your customer, anti-money laundering, etc., where a lot of the innovation starts touching more and more those core systems. And a lot of our customers are facing now with the challenge of how do we actually modernize that core so that these new requirements can be adopted much faster. Or like with the example of one of our customers, Banco Itaú, one of the leading South American banks, is like the entering of neobanks has also disrupted a lot of those banking services. How can we respond to the fast-moving neobanks and catch up with features and also with the digital experience that these neobanks have? So one pattern that we saw, and that was also Banco Itaú doing that at scale, is to migrate the core. You completely rewrite everything that you have done before and then build a new system. With Banco Itaú, this is many million lines of code, several hundred million lines of codes that need to be transformed. We had also other banks here in Europe, and for those that are interested in how that approach works with today's technology, not just ML-based and rules-based, but also with generative AI, we have a booth at AWS World. It's called AWS Transform, where we show how that approach from Banco Itaú, also other European banks, works, and how we can migrate COBOL code into something more native. And we are no longer doing just rule-based transformation from one code base to the other, but generative AI helps us now to deeply understand what that code was doing, write specification, test cases against it, and then completely write something new. So it's no longer COBOL code looking like, or transformed into Java and then still looking like COBOL code. It's a completely new setup. For larger banks, that's a potential option, but we also have a lot of smaller customers that don't want to write their own core. So they want to purchase something. And they used either a neo core or just purchased a digital native bank and then launched a new digital brand under which they can actually do then the new requirements or fulfill the new requirements and then shift customers towards the new solutions. These neocores, however, are limited in the functionality. They are working very fine if you're just doing accounting and payments, but seldom they come with features that are required for other segments like small, medium entrepreneurs or private banking, wealth management or asset management, which require much more functionality around it. So these banks have started to decompose their core and then replace parts of the core with new components. For instance, you have a customer relationship management in the core, and you're now purchasing a SaaS solution, move the customer relationship management functions into the SaaS solution, and then compose the banking solution with that. And that's also what we want to talk about today, but there is one risk with this approach, and that is that you're replicating the monolithic structure into a distributed monolith, which means like the dependencies need to be managed such that you're not interconnecting so strongly that if one component fails, nothing works anymore. So we want them to be independent, and that's a good segue over to Joel from Avaloq, who is going to talk about the business driver behind that migration.
Thank you. Thank you, everyone. My name is Joel Lewis, so I'm here from Avaloq today. For those of you not familiar with Avaloq, we help our clients operate their wealth management operations throughout the globe. The companies we support have a little over 4 trillion Swiss francs of assets globally. So the way we help them is with the full value chain of operations of a bank. So as Roger mentioned, so retail banking, checking accounts, savings accounts, credit cards, traditional loans is something we support on our platform and something a lot of neobanks support. But what differentiates Avaloq is our expertise with the more complex products that wealth managers support. So, supporting real estate investments, securities, private markets access, other alternative assets, derivatives. You name it, 20 plus different asset categories that are supported on our platform and used by our customers to support their end clients' investments needs. The more wealthy the end customer is, typically the more complex their needs are, and the less standardized our banking institutions that we support can be in how they deliver solutions to their end customers. So, what are our customers' challenges? Well, the end clients are looking for personalization, access across channels, and a unified view of their investments, among other things. What I mean by all of these things, so if you think about a complex client situation, typically they're doing business in more than one region. Historically, banks have had to support people, not as people, but as accounts. So an account in a region under a certain regulatory jurisdiction. That feels like a very disjointed experience to the customer. They think about the institution they're banking with, the accounts they have across all of those different regions, and typically they'd like to see a single view of all of their assets at that institution, all of their relationships with that institution. As Roger was mentioning, there's often multiple cores involved with keeping track of all of that information and maintaining all of those regulations across different regions. And a lot of complexity for the bank in stitching together a unified view for that end client so that they can see a picture that feels like their situation and maps to the way they think about their finances in their head. So when we think about what the financial institutions we support are looking for, they are looking to stage that transformation and stage that stitching together of their disparate systems at a pace that they can manage, but also at a pace that's meeting their clients' ever-growing needs and expectations. At the same time, as we're hearing about all day in and out of this conference, also looking to take advantage of all of the advantages of the cloud and all of the advantages that new technologies like generative AI bring to bear. So as we heard this client feedback, we thought this was a unique opportunity for us to take a different approach in how we build and deliver solutions to the banks we work with. But to get a little bit more concrete, so some of the concrete challenges that have been shared with us. First, the institutions we support are increasingly growing in scale of who they serve and the complexity of who they serve. So institutions that focus more on trading or more mass affluent customers are looking to get increasingly upmarket. Institutions that focused on private banking and high net worth investing are typically looking to support down market customers. Think the next generation of wealth, the children of their current customers. With that comes a challenge of supporting greater product complexity, more just scale of portfolios and accounts, and often more positions in those accounts. Their existing systems and cores often can't keep up with that scale of growth that they're trying to drive in their business. On the right-hand side of the screen, to get a little bit more specific again, something we commonly hear is that when it comes to the topic of performance reporting and measurement, so basically, how are my investments doing? Is the financial institution growing my investments, protecting my investments? Are they keeping up with benchmarks? How should we be evaluating what my portfolio looks like and what changes should we be making? The systems that run that, again, as I mentioned, often siloed. So we hear about a lot of the institutions we work with having to go into tools like Excel to take data from multiple systems and stitch together that unique view of the customer. Where there are more performance systems involved, we often hear that updates to the entire financial institution's book of business can take hours overnight and often fail, leaving the relationship manager unable to start their day effectively, unable to answer that phone call about how did my securities do yesterday? What's my performance looking like after something happened yesterday? So in order to solve all of these problems, we thought this was a good use case for a modern cloud-native solution. So one, taking advantage of the cost and performance capabilities of a cloud-native solution. And then second, delivering it in a more composable way. So instead of having to consume the full value chain of a bank, being able to stage what changes, what transformations do you as an IT manager of a bank want to make at what time, and how do you want to shrink the change that you're asking your organization to go through. I won't read every word on this slide, as I think we all know some of the advantages that if you do the cloud well, you can get. But with that said, I'd like to hand it over to Didier, who will walk you through what we built to start with and how we're solving some of those problems for our clients.
Thank you, Joel.
Thank you, Didier.
Yes, hello. Here we are. We are ready. Yes, I know. Oliver, a year ago we pitched to you unsuccessfully and claimed to be ready, but now we really are. And we have started the first implementation project with banks who give us their trust. So our first composable module is called the Investment Book of Records. What does this module do? So it consumes data such as bookings, prices from source systems. Derived on that, it calculates the positions, their balances, investment performance, risk metrics, and of course then all kind of aggregations, so like portfolio level data, asset allocation based data, and this is kind of the fundamental basis for any kind of wealth management. So if you have an end client looking in his app to his portfolio, so this data is consumed from such an investment book of record. If you have a portfolio management system where the portfolio manager has to do rebalancing decisions, monitor constraints, this is based on this investment data. For advisory, if you do proposals, need to keep compliance with all regulations such as MiFID, this is based on this investment data. So now you might say, yes, sorry, a performance engine, that's not something new. That's done already many times. And yes, you're absolutely right. But I think in all false proudness, we did it much faster, better, and more cost efficient. So traditionally, this data was calculated as kind of a side product from core banking systems and portfolio management systems. Those systems, they have a clear goal and focus, which is not to deal with large amount of data. So, for example, core banking systems, they're focused on having the bank's booking point of view to be compliant with IFRS and all this, but they're not ready to serve large time series to be used, for example, in client reporting or in data lakes where you want to do analytics. So we decided to go cloud native, and we have now the first results available. So one use case is typical end of day or batch processing. So it's still there. So a typical example is periodic client reporting, where you have to calculate performance reports for potentially millions of portfolios. You have control reports where you have to find for loss thresholds or kind of extracts to third-party systems. So while this was taking originally kind of hours for this amount of portfolios, now it takes minutes. So really we achieved like factor 1,000 in scalability compared to our previous experiences. If you look to a bit more modern integration patterns, so near real-time and ad hoc reporting. So here, of course, the key is to be highly efficient in sense of a latency. So even if you look at a big portfolio, we need to be able to deliver that within 1 or 2 seconds. Now, unfortunately, here is maybe not the right place to go too much to the functional scope of our investment book of records, but maybe still some highlights. Of course, it supports classical performance like time-weighted rate of return, money-weighted rate of return. We cover all kind of corporate actions and product types. We have performance attribution, exposed risk metrics, all this kind of things. Also, we have kind of a lot of very nice features. So, for example, periodic cost values, allowing a proper split of P&L views. So, yes, if someone is more interested, I'm happy to follow up on the functional side. We decided to go with a cloud native approach. So no hybrid or cloud agnostic. We focus on a very few services, but those we really use to the maximum performance. The computation, we decided to rely on AWS Lambda because we have use cases where we have kind of high peaks. So imagine a periodic client reporting. So a bank needs to provide 1 million client reports in a short amount of time. So using AWS Lambda, we can scale for these peaks, while at times where the usage is a bit lower, we can also scale down again. For data storage, we rely heavily on S3 and DynamoDB in a very classical pattern. So in S3, we store the large amount of data, while DynamoDB is mostly used for metadata and also for our internal locking mechanism. Now, of course, we didn't put it on the lessons learned later on, but the big topic is always security and compliance. There's the technical part. So yes, of course, you have the encryption in transit and rest. You have customer-managed keys, separation of customer-sensitive data. But the real thing is to integrate into the security process of a big company. And there, it's not uncommon that you have different priorities. So, for example, your security officer has some ideas how to do it, and we say, does this really improve the security, or does it just make AWS richer? But at the end, I think it was Bill Clinton who said once in his next life he wants to be born as a bond market. So me, in the IT, I would say in my next life I want to be born as a security officer. So they always have the last say. Yes. So of course, relying on a cloud-native stack, I think it unleashed kind of the potential, and it showed us what is possible compared to our previous experiences. But still, of course, there are many patterns we still had to find that work for ourselves. Also we have to contribute somehow. So one aspect is the productization. So our ambition is to have this kind of composable modules, such as the investment book of record, that is not deployed at one bank and maybe the second bank we see what we can reuse and somehow deploy it manually again. But our ambition is really to serve hundreds of customers globally with this solution. This means we have to make many things, many thoughts about productization approach. Data modeling and data design is of course key for any solution in this space. So I don't know if anyone is familiar with the existing our core banking data model. Yes, hands up, not so many. I mean, of course, I'm biased, but I would say it's a very nice data model. So we model like what is a portfolio, what is a sub-portfolio, what is a mandate, what is the contractual relationship of the customer with the bank, who is the customer, what is, and this kind of modeling, if it's done wrong, it will hurt you a lot. So one thing we did probably wrong many years ago in this data modeling is we forgot about an entity or a business entity called a person. So years later, we noticed this, that we have to introduce an entity type person in our core banking system. And this, we had to rewrite every single engine in the core banking. All our customers had to adjust their interfaces and their logic on it. So I would say in the Swiss and global banking industry, we cost this decision we originally did, maybe more ad hoc, cost millions of Swiss francs. So the data modeling and data design is key, and you need to do it right from the beginning. Last not least is the consistency. So when you know we have a banking landscape with different systems, and it's a key and a huge operational effort to keep all the data consistent. So we had to find an approach how to ensure this data consistency, and I will give some words about this. So first, when you look at the productization itself, obviously, as already the name says, we decided to go for composable modules. This means each module, such as an investment book of record, or it could be a corporate action module, instant payment module, but each of these modules contains its own business context and can be operated standalone. So of course we have to some extent to pre-integrate the different modules with each other, but at the end it gives us the possibility, and also our customers, to introduce one module at one time, at another place maybe use a competitor of ours, or do something on their own, and especially not go for a big bang monolithic transformation, but to decide to go with one module and then later with the other. Then the layering and integration first. So the layering, I mean, if you go to a bank, every bank will tell you, we are standard. And then our management will go to the bank and say, yes, they're standard. The first workshop we do with, let's say, private banking, you find out, yeah, kind of standard, but even worse, then you have the next discussion with the asset management, and they said, yes, but private banking, they do it like this. But we do the benchmark calculation completely different, and there's good reasons. So the reality is that there is no such thing as a standard bank. That's just, I mean, no one wants to hear, but it's not the case. So we have to deal with that and find a way that we don't compromise our solution. So I think a trap that many SaaS providers or product providers go into, they build every request or what they get from a customer over time into the same core. And so if you do that, you lose completely control. So what we had to do is a clear separation of configuration and also giving access to the customer to doing that and say, look, dear customer, you can do some specific functionality and processes, and here you can configure it, and the core. So we clearly separated these two layers. An additional aspect is our API-first approach. Yes, it's a buzzword, but it's really a different way of starting the implementation or development. So instead of building a functionality and later on decide how we can make that available somehow externally, we started with the APIs itself, and we're thinking how will the functionality be used, how needs such an API to be looked at. Last not least is the SaaS platform. So the application is just, so the business functionality is just one aspect of the solution. But we also need to be able to operate it efficiently on our side. So meaning we have operation teams who need to access the logging, who deal with problems. We have to onboard new customers quickly. So it really needs to be repeatable and scalable, despite also sometimes having banks not being 100% standard. So we put a lot of attention on what we call the SaaS platform aspect. So the data modeling, as I mentioned, is the key, and something when you did it wrong or completely wrong at the beginning, it's very, very hard to correct later on. So whenever, in my view, is whenever you decide to build a banking product or a solution for wealth management, this is where you really need to be sure that you do it right. Next topic is, of course, how do you store this data, in which way? Traditionally, we come from a relational database world, where you have you model it normalized, and you have your tables. If you need a new field, you decide at which table you add a column. As we decided to go with S3 and DynamoDB stack, we completely turned it around and went the denormalized data design approach. I made a concrete example. Of course, it's a bit simplified. So we have, let's assume we have two portfolios, a portfolio A and a portfolio B, and both portfolios have certain holdings. So what we do, we store in S3 the portfolio as an entity. So the data is stored in the entity it's used, also later when it's consumed. But now, of course, you have different use cases. So you might want to know which portfolios hold a certain security. So this means you cannot just make a relational database join, another query, but you have to do a separate bookkeeping for the securities. The complexity of this is, of course, to ensure transaction safety. So meaning we do the booking on the portfolio accounting side, and then we do the booking on the security side, and one side has maybe a problem, or we did something wrong and it crashes. We still need to have the consistency. And we cannot just, as in the good old world, use the underlying relational database mechanisms to provide that, but we had to found a known transaction safety concept. Here we rely heavily on the atomic write from DynamoDB and use an optimistic locking to scale that for large numbers. Next topic is to deal with backdated events, which is crucial, and you might not think that it's important at the beginning, but at the end I would say it's the heart of our solution. So in reality, when you work within a bank, you have often different systems and things change, so you don't have a now in time. So a good example is you have on a source system, you need to correct some data, maybe there was a mistake, maybe it's a reversal because a corporate action was booked wrongly. So this means you don't want to have an operational employee who goes to the second system, all the other systems, adjusts it, runs the job to also fix the data, but you want to automate this kind of backdated corrections. So here there are different approaches. So of course many systems, they have kind of end-of-day processes where they look for deltas and correct that. More modern systems have ongoing background processes who always detect, oh, something backdated has changed, but we went to a so-called pull principle. So by design, each entity is responsible for its own consistency at the point in time when it's used. So let's make a concrete example. So we have two portfolios holding a certain financial instrument. Now you booked it already, you made maybe already some reporting, but now you get a different price in the history. So how do you deal with that? So in our case, when this kind of backdated event happens, at the point of time it happens, we kind of do nothing. But we say, when an entity is consumed, so for example an ad hoc report, a periodic report, or a controlling, at this point in time the entity is responsible to bring itself into a consistent state. So concretely, in these arrows, we see here we have a business event, a backdated security price change, and then later on portfolio A is consumed, for example periodic reporting or a loss control. So at this point in time it needs to bring itself in a consistent state. So this pattern has the advantage that I would say 80% of all this flow coming in backdated doesn't need to be computed because an entity will never be consumed at this stage. So with this pool mechanism, we estimate to save around 80 to 90% of computation. However, the disadvantage is if you have, for example, periodic control reports or a batch reporting, at this point of time we have a huge peak of things we need to bring in control backdated, and here is where Lambda is perfectly suited to support us. So what are our key learnings, or what are our principles and what is important to us? So in well space, so our key let's say opinion is that it needs to have expertise. So when you model your APIs, you need kind of to know how will the data be consumed by another system. If you do the data modeling, the application, there is a lot of complexity, and if you have just very technical people, they can be as competent as they can, but it doesn't help. You need to have banking expertise. Now, on the other side, if you go with a lot of experienced people, so they will, on the technical side, typically use the same patterns as they always used, including me, honestly. So you see kind of a problem, say, oh, let's do another background process to do that. But here, the main challenge is that we have to unlearn patterns, and for each thing where we intuitively say, yeah, let's do it like this, we always did it like this, we have to acknowledge that we have to sit back and think if we find a better way to model it and leverage also the cloud native advantages there are. By everything we do, and this is much more transparent also for the engineer than before, is the cost aspect of the design. So previously, as a typical engineer, you were only indirectly confronted with the cost. But now if you're trying to leverage cloud native services from AWS, kind of every design you do, kind of every decision you do, has a direct, especially in a serverless world, has a direct implication to the infrastructure cost you will produce. So this needs to be a key aspect or key philosophy for everything you do. Then, of course, also the operational cost. So it's not only how to implement it and how the infrastructure costs will be, but also the operational part. So for everything we do, we need to know who will look at the logs, what needs to be in the logs, how is the flow of the data, which people are deploying. So this aspect is quite crucial. In this regard, also for our customers, so the banks and wealth managers, we also need to be sensitive where we produce cost on their side. So there can be back office, staffing, and the like. So for everything we do, we need to think how can we reduce the complexity and the cost for the people operating it. So one aspect of this is what we call the SaaS platform design. So the SaaS platform is exactly all these things, surrounding things around the application. So how is our organization set up? If we onboard a new bank, what will be separate? Which kind of things like the control plane can be reused? How do we do the deployment? Which kind of releases do we keep in sync? And this is also quite, I would say, 50% of our job to ensure this kind of SaaS efficiency. And here I would like to give a big thank you to our colleagues from AWS, because we really get a lot of support, sometimes even more than we ask for, but really a big thank you for all your help in this regard. Yeah, many thanks. And then I would like to hand over back to you.
Okay, and also thank you, Joel and Didier, for the interesting talk. I took away quite a lot of things for myself. First of all, like modernization, it doesn't have to be like banking modernization. You've seen the technologies in use. Also ask us to think about new ways of how we develop this architecture. So the traditional relational database model is still fit, and a lot of our customers are using that. But you've seen, like with the scale here, with the example of portfolio calculations, these native architectures have a lot of advantages, but also require different architectures and different setups to succeed. Now, invite you all to come also to the AWS Financial Services booth, where Joel and Didier will be available for some time for further questions, and you can ask also technical details. We have also other interesting booths that are going in this direction, like I mentioned at the beginning, the AWS Transform booth, where we show you how you can automate that migration process and what are the tooling behind the scenes that can help you to do more with the skills and capacity that you have. And we also have various other interesting booths where we look into serverless, event-based architecture, and also other interesting technologies that you can actually use to build your next system. Most importantly for us is also your feedback. You see the survey QR code, so please use the survey, give us feedback, and help us also to optimize the summit then for next year. And with that, thank you very much for your attendance. Thank you, Joel and Didier, for presenting with me.
Thank you for having us.